Hello, everyone. We are here for our today's webinar, working with coordinate systems and survey data. Here today with me is Craig. I will do a quick introduction, and after that, we will ask Craig to show the technical parts. Before we get started, some housekeeping items. Everybody is muted today. However, you can ask your questions and engage with us through the Q&A section of the GoToWebinar panel. Also, as usual, we'll be recording this webinar and later on available on our YouTube channel. Quickly, upcoming webinars. We're going to have a series of webinars coming up. Next one on June the 22nd, Software Optimal with Civil 3D. That will be in version 8, the latest version of RoadEng. And then how to use terrain tools for site designs on July the 12th. Working with multiple alignments, August 9th, and new feature actually to review for the upcoming release. That will be working with live maps and events of PDF are the new features. That will be on August the 29th. All the webinars are at 11 a.m. Pacific Standard Time Zone. Yeah, you can get more information through our website. That being said, I'm going to let Craig take over and show you this the software. Are you ready, Craig?
I'm here and I'm ready. Just do the screen switch.
We'll give it to you.
Okay, show my screen.
Yes.
Okay, you see some mountains. That's my screen, and I'm just got a couple of PowerPoint slides just to introduce a few things. So, well, first of all, good morning or good afternoon, everyone. This is going to be about coordinate systems, and I think it will be one of my shorter webinars. And I'm going to jump around a little bit because I want to illustrate some different concepts. So I've got some examples from forestry and civil. And yeah, I'm going to jump around and please interrupt. There's a panel where you can enter questions, interrupt me as we go. I think that's probably the best way to deal with it. And yeah, let's jump right in here. So most of you, I'm sure, know about coordinate systems if you're doing engineering type of work. They'll certainly be familiar with, you'll be familiar with them. So here are a list of some of the common ones that are used, and there's many types of systems all over the world, projections. And ones that we find quite commonly used here are UTM, of course, and south of the border state plane system is quite widely used. All of these systems on the top here, they're under a category called Cartesian. And then below that here we have a type of system called lat-long. And Cartesian coordinates really mean that you can measure distances and angles with the coordinates. Without getting too technical, you definitely, if you're doing any kind of engineering, you definitely want to be working in Cartesian coordinates. Some people bring in lat-long coordinates and they want to work with them. It's not a good idea. I fully discourage it. What you want to do is, if you need to bring in lat-long coordinates, convert them into a Cartesian system to work with them. And I'll be talking a little bit more about that as we go. So what are the benefits of knowing where you are on the map, essentially? First of all, if you know the coordinate system, you can combine data from different sources. So you can bring in maybe LiDAR in one projection. You can bring in imagery in another projection, traverse field data, and you can combine them very easily if the coordinates are known, if they're in known systems. and you can convert between them. It also lets you work with your data using GPS because it's georeferenced. Now the GPS understands where it is, and you can use it with GPS. And finally, there's a lot of sources of data now on the internet, and there will be in RoadEng, where you can actually just connect to a data source, download information, and you will have map data right at your fingertips. And so having and working with georeferenced coordinates is very useful. And yeah, I think more and more people are getting familiar and using coordinate systems. So that's my couple of PowerPoint introductions. I will now just jump in here. I've got an example of a couple of roads and a couple of cut blocks, and I happen to know that this data, I happen to know what coordinate system it's in, and in RoadEng, the coordinate system is set up under Setup, Module Setup, Projection, and in this case, I am working in UTM coordinates. I'm in NAT 83, that's my datum, and Zone 10, very common here in British Columbia. Some other systems that we support, I mentioned on the entry slide, state plane, lat long, again, we discourage that for use. And there's a lot of others. You can actually create other systems, and I will talk a little bit more about that in a minute. So for UTM projection, we have a lot of different zones, and it's important, of course, to get your data in the right zone, or it won't be on the right place on the planet. So yeah, let's have a look at this data and check it to see if it's in the right place. And I find that Google Earth is a great tool for explaining stuff to people, but also for checking coordinate systems. I can very quickly check that this is in the right place. And in version 8, I just go Export, All Features, Update in Google Earth, and we should see this data, if it's correctly, it's got the correct projection on it and the correct coordinates, it will land in the right place. And there it is. I know it's correct. I'm familiar with this data, so that is a great way to check it. If I got my coordinate system wrong, let's just do that for a second. Let's change coordinate systems. Let's suppose we think that this is in another projection. Let's suppose we think it's in zone 25. And I do the same operation. It's quite quick to do this. Export, All Features, Update in Google Earth. And now we should see the data land somewhere where it doesn't belong. In this case, looks like it's in off the coast of Labrador somewhere. So clearly it's not the right projection for that set of coordinates. Now, some confusion arises where people think that by going into setup here and changing this coordinate or this projection that their data, their coordinate values will change. That's not the case. You can see here, if we click on a point, you can see down here in the right, those are the coordinates, and those coordinates only make sense in UTM zone 10. If I change the coordinates to another system, you'll see new coordinates there, and those coordinates, of course, will only apply to that new system. So let's bring in some outside data. I mentioned that having your data georeferenced is very useful now that you know where it is, so I can bring in some other types of data. So let's go ahead and insert a file. And I've got a GPS track from the same area, and I'm going to bring that in. And GPS and KML files work in lat-long coordinates, and they're known to work in lat-long coordinates. So on the left-hand side of this mapping, you can see that it's got lat-long coordinates set, and I can't change it. That's what it is in the file. It's known. And what it's telling me here is it's going to convert from these lat-long coordinates into our current projection, which is zone 25, which is silly. Let me change it first. Let me go back to where I was. Let's go back to zone 10 so we got something that makes sense. Okay, we're back in where the projection we should be. Let's do the insert again. Our GPS file. So it's going to convert from lat-long into UTM zone 10. And because it knows where zone 10 is, it can get the lat-long coordinates to match up, and now the lat-long has been converted into UTM zone 10. The other thing we might do, that's a case of a file that knows its projection. It knows what coordinate system it's in. If I was to bring in an ASCII file, that wouldn't be the case. If I had some total station data, let me insert it. I would be looking at a file that is kind of dumb. It does not know where the coordinates are. So let's just go ahead and bring this in. I'll use a standard ASCII import spec to read it in. I set this up beforehand, so it should work. I'm going to read it in. Now I get this message that I'm sure many of you have seen. Incoming coordinate system and units are undefined. So doesn't know where they belong. Hopefully they land in the same coordinate system as the other data. So I'm just going to go ahead and bring this in, and there. Luckily they do. So I know that ASCII data was in UTM zone 10. Now, interestingly, let me just delete this, click on this and delete this also. Let's change this coordinate system to another coordinate system. One that's very common here is BC Albers. So I'm going to select these features, and I'm going to Feature Tools, Transform, and I'm going to go to UTM zone 10. That's my current system, and I'm going to convert it to a new system. I'll come back to all this stuff in a second, that I'm going to get from a number called an EPSG number, which is a standard GIS projection. It's a standard. So I know that 3005 is BC Albers. So when I do that, I get all this information. I won't go into what it is, but it is all about the projection spheroid and the type of projection and central meridian. A lot of quite complicated stuff, but I got that all from this number 3005. It set me up in a system, and that system is commonly referred to as BC Albers. So I could have chosen any other system, any other projection from my list where we previously were, but I've chosen this special system called BC Albers, which I got to through what's called an EPSG number. So let's just go ahead and do this, converting our data from UTM zone 10 to BC Albers. Press OK, apply transformation, and it's gone. It disappeared off the screen because my screen coordinates are still in UTM zone 10. You can see down the lower right corner the coordinates showing there. So all I have to do, zoom extents, and now I'm in a new coordinate system everything else is the same, but now I'm in a new coordinate system, BC Alberts. And to check this, again, to check it, Google Earth is very useful here. Home, export, Google Earth. I'm going to export everything again into Google Earth. And if all went well, I did the conversion, it knows about the new coordinate system, it should be in exactly the same position. Good. We didn't make any mistakes. So we've actually changed the projection of our coordinates, and it all lands in the same place. Now, let's just go back on this example and now try and bring in, first of all, let's bring in the GPS again. We're now in a new coordinate system. Let's see if that works. So I'm going to insert file, go back to our GPX file. And it's in lat long, I have any choice. And on the right-hand side, BC Alberts, so it's going to do the conversion and apply the transformation, and bang, it worked. Now let's try the ASCII file, which doesn't have any information with the file about what projection it's in. So insert file, ASCII file, the total station file. And again, I'll choose the default. And again, I'll take all the default settings. And now it's come in, but it's not visible on the screen. It was down here before. And let's see what happened. I'll do a zoom extents. And there, I've got some data down here. You probably experienced this at one stage or another. That's all my map data. And here's my imported file, or yeah, here it is up here, and I'll just zoom in on it, and there it is. It's in a different coordinate system. It's in UTM zone 10, and my data has been reprojected into BC Alberts. So to fix this, I can simply select this guy and do and reproject him. So terrain, our feature tools, transform. We're going to tell it on the right-hand side, or sorry, left-hand side. We're going from UTM, zone 10, and we're going to convert just this one feature into BC Alberts. Apply transformation, and there you go. So the advantage of having things georeferenced, one of the key advantages is you can get data from different sources, different methods of acquisition, and bring it together and tie it together easily. And then at the end, you can deliver something that is georeferenced. You can use GPS with it, or you can send it to your GIS system. Yeah, one thing I just wanted to finally note on this example is I'll reopen this file, and it's back in BC Alberts, and I'm going to insert an image. Sorry, insert file, and it's an image. Actually, an image that was generated by our software, but that version's not yet available publicly, but kind of a sneak preview. So we can download free imagery, low quality free imagery from the internet, bring it in, and there it is. Now, again, the imagery has been georeferenced correctly. So this image, which has a little companion file with it, which tells the software where it is geographically. So yeah, that's essentially the use of georeferenced information in terrain, and it follows through into location. I'll show you some examples quickly about that. This would be a good point if there's some questions about what I've talked about so far, because I'm going to change subjects a little bit. Time's up. Okay, we'll press on. So I'm going to minimize this, and I'm going to switch over. Oh, yeah. By the way, for those who work with survey, if you had a survey, a Traverse file, and you wanted to get it georeferenced, all you'd have to do is to set this starting coordinate. And I go in here. Where is this? Traverse, there we go. And I can set that starting coordinate by right here, set get coordinate. And here is where you would put in the tie point into your UTM coordinate. So even if you hadn't picked up a coordinate in the field, you could do it later by entering a coordinate here. That's kind of a different subject. Leave that one for another seminar. But this Traverse would then be georeferenced. So I see time is ticking here, so I'm going to push on to
Craig, we do have a question, actually.
Oh, okay, sorry. Could you read it, Parshid?
Absolutely. Absolutely. It says, can we import a Google Earth background into the train file directly from the Google Earth?
Good question. And in version 8, so far, no. You have to do it manually. In the coming version, we have actually an import option. We don't use Google Earth imagery. We use free map imagery, but some of it's pretty good quality depending on the area you're in, and it's free. We can also bring in DEM data. Again, the quality is pretty poor, but it's free. So yeah, those are the options. The actual Google Earth imagery, I think there's some utilities out there that will capture it. I think it might be copyright. I'm not sure, but we're using a different product to get the imagery, and I think a lot of that is based on public domain imagery that's been flown by organizations like NASA and things like that. So again, the coming version will allow you to do that. It's free, and you will also be able to get crude DEM data directly from the internet just by loading it. So yeah, you can look forward to that. I think we'll be going to beta soon on that. So I'm in the road design part of the program, and I just wanted to very quickly show you, this is a highway design. This particular data has been georeferenced. I just want to show you a couple of things that you can do to get coordinate information out of RoadEng. So I can create a data window. I can add various columns to it. Let's just remove some of these quickly and maybe add station, or centerline elevation and station. That's an obvious one, the centerline elevations. I could also add point codes in here. For instance, like a ditch, point code, let's say DILX, DILY, DI elevation. Those are ditch inside left, X, Y, and elevation. So I can add those into my data window, and lots of other things. And this is really a quick way of getting coordinate information out of RoadEng. So there I've got a data window. It's showing, I guess I left some grade cut field in there. But anyway, these columns here are coordinate information, and I can copy those to the clipboard. Right-click, copy data window to the clipboard, and I can go over and start up Excel. Or save this to an ASCII file, but we start up Excel, paste this in here. Yeah, so this column's not so important, but the others, you can see you've got coordinate information this way. You can work with that. Another common way these days to get coordinate information out of it out of RoadEng, just save this as a land XML file. Most data collectors support land XML to some extent, so I can save this as land XML. And what it will export from this option is the centerline alignment, including curves for horizontal and vertical curves, and cross sections based on a specified layer. So it won't directly from location, won't export a surface model, which some data collectors want, and I'm going to show you how to do that. The good news is in the coming version, you can do all that from this one menu, much easier than what I'm going to show you. Yeah, so this export of land XML includes all the coordinates and cross sections. Most data collectors will accept it. So the other thing I wanted to quickly show you is to save this file in a terrain format as a surface, so we can get a surface XML file. So in that case, I would switch to a terrain format. I'll call this 1. Save this as a terrain format, and I'm going to first of all choose all the points to save. And I'm going to choose the final surface. I had some options here of different surfaces, strip surface, subgrade surface, and so on. So you pick what you want. Just remove these. I don't bother with these if I'm exporting this way. So I'm going to export all the cross sections of the merged surface. I'm going to create a terrain model, and I'm going to open the terrain model automatically. It's done that. Let's quickly create a 3D window, tile these windows beside each other, and I'll just zoom in here and you can see what it's created. It's created the surface within the extent, the disturbed limits of the road. So yeah, that then can be saved as a land XML file, save as land XML. And that can be loaded into a data collector, and that will save the service. Yeah, that's, one more thing I want to quickly show you, an advantage to georeferencing a file is that you can work with GPS in RoadEng. So I have here an example file of a fantasy alignment that I created in my spare time. Our office is just here. So I created a bike path that runs beside our building down towards a major road down here. This is totally ridiculous. I think the bike path even encroaches on some buildings. But what you can do, because this is georeferenced, is to enable GPS in RoadEng. I've got this file all georeferenced, so I'll just take it maybe out on my laptop in the field, and I'm accessing the GPS. I'm in the office, so I don't have a proper GPS, but I have something that uses network connectivity to locate me. So it acts just like a GPS. And there we are in the office, and here is my cross section. It's showing me an error band of where I might be horizontally and vertically. And if I walked along here, I could see this. So it's an advantage. And of course, because this file is georeferenced, you can take it out in the field in other ways, things like Avenza maps or shape files. All that stuff is now enabled for field use, so it's very useful. Yeah, that's all I got.